Welcome back to the Foundations of Science series. In this episode, we'll be exploring the fascinating world of measurement and units. If you enjoyed our first video on the scientific method, don't forget to subscribe to our channel and give us a thumbs up. And if you haven't seen it yet, be sure to check it out before diving into this one. Also, feel free to share this video with anyone who might find it interesting or helpful. So let's get started and learn more about the fundamental tools of scientific inquiry. In the previous post, we discussed the foundations of science. In this post, we will examine how measurements are made and how they are used in science. Measurement and units. In science, a unit of measure is a physical object or system that is used to measure a specific quantity. Units of measurement can be divided into two categories, fundamental and derived. Fundamental units are the fundamental dimensions of space. For example, length. Time, for example, seconds. Energy, for example, joules. Mass, for example, kilograms. Derived units are derived from these fundamental ones. For instance, kilograms are converted into grams by dividing them by 1000. Degrees Celsius are converted into Kelvin using the function formulae. Inches feet were originally based on foot lengths, but now tend to be measured as inches instead. Due to their convenience for everyday use, sample size. Sample size is the number of samples you take to measure a parameter. The sample size should be large enough to detect any change in your parameter, but not so large that it takes too long to get an answer. For example, if your experiment involves testing one group of individuals with respect to their gender identity, male vs female, then you will need at least 50 subjects per group for each sex combination in order to get statistically significant results after multiple tests have been performed on each combination, e.g., 100 males and 100 females. The same principle applies when comparing two different populations. You're probably not going to be able to find any differences between them unless there are at least 10 people from each population tested individually. Precision. Precision is the degree of closeness to the true value that a measurement gives. For example, if you measure your height as 6 feet, but you're actually 6'2", your measurement is not precise because it doesn't give an accurate answer. Precision is also used when measuring things like distance and weight. 1 meter, 100 centimeters, 1 kilogram, 1,000 grams, 1 kilogram, 1,000 grams, 1 kilometer or 0.62 mile. This unit system can be repeated over and over again without error because each repetition will give precisely the same result each time. No matter how many times or how far apart they are repeated, the closer two numbers come together by using more precise measurements, like multiplying them, then those two numbers will become closer together in terms of their relationship with one another on an absolute scale too. Calibration standards. Calibration standards are used to determine if a measurement is accurate. They help you compare your results with other measurements so that you can verify your methods and improve them. Calibration standards are usually very small samples of the material being measured, such as grains or flakes of metal or plastic. These have different properties than the bulk sample. They may be softer or harder than their surroundings, for example. And they can be used to check whether your instrument is working properly by comparing its reading against those from known samples. Significant figures and significant integrals. Significant figures and significant integrals are two of the most important concepts in mathematics. Significant figures are the number of significant digits in a measurement, while significant integral is the area under a curve between 2 points. In order for you to understand these terms, let's first look at some examples. A measurement such as 2 km has 4 significant digits. The decimal point tells us there are 3 decimal places. This means that we can use this number when making other measurements. For example, calculating how many meters it takes to get from one point on Earth to another point will give us an answer with 6 significant digits. Torque-me Juanzerosome. Similarly, if you want your car's speedometer reading to be accurate enough so that it says 24 miles per hour instead of 25 miles per hour, then subtracting 1 mile per hour from your current speed should give you correct result. The scientific method is about the use of repeatable experiments. The scientific method is a way to test hypotheses, and it's how science works. We use it to find out whether our ideas are true or false, and if they are correct. The scientific method starts with an idea that you want to test. You might have an idea about how something works. For example, you might think that eating fast food causes obesity because it leads people to eat more than normal, a hypothesis. Or maybe you think there are aliens living on Mars, a hypothesis. In either case, your first step would be making sure your hypothesis makes sense of all the evidence available at this point in time by testing it against existing facts or data sets. For example, does fast food lead me towards more unhealthy diets? Can we prove that aliens exist? Measurement and units. Measurement is the process of determining a quantity. It's used to describe a number, especially when it comes to size, shape, and position. For example, the room is 30 square meters. Measurement is also used to describe time intervals between events, e.g. It took 3 hours for him to paint his walls, or the sun rises at 6 a.m. Measuring instruments can be classified into 2 groups. Physical units such as kilograms or centimeters, and non-physical units such as seconds. The scientific method is an integral part of science. The scientific method is an integral part of science. It goes like this. You make a hypothesis, which is a general statement about how the world works or what you think will happen based on limited information. You conduct experiments and collect data to test your hypothesis. If your hypothesis is correct, then you can conclude that something is true. If it's wrong, then you can conclude that something isn't true, and maybe rethink your entire worldview. The scientific method is a fundamental part of science, and it is the key to making accurate measurements. In this article, we've covered how measurement works in science. We looked at how units are used to measure things like mass, length, and time, how precision is important for making sure that measurements are accurate, and what makes standardization possible. We also briefly touched upon the history behind these standards and how they were developed over time from being merely guidelines into actual standards that are required by law across nations today. Thank you for watching this episode of Foundations of Science. I hope you found this video informative and enjoyable. If you did, please don't forget to like, share, and subscribe to my channel for more science-related content. Also, don't forget to check out the previous episode on the scientific method if you haven't already. As always, feel free to leave any comments or questions you may have in the section below. Until next time, keep exploring the wonders of science